Hello, I'm glad you could be here. We're going to be taking a journey to discover taste. Coming along with us will be some friends from around the world. So, let's get started.
Hi, I'm Skylar from the United States, and I love turkey, rice, and vegetables.
My name is Laki, and I am from Bangladesh.
Pasta is so delicious. My name is David, and I'm Italian.
I'm Lydia from the United States, and my favorite thing is pizza.
This dish is so good. My name is Denise, and I'm from Argentina.
Hi, I'm Chris from the United States, and I love homemade hamburgers made with grass-fed beef.
I like this dish. My name is Sammy, and I'm from Morocco.
I'd like to ask them something about this ice cream. It looks really good. What flavor is the ice cream?
It's strawberry and chocolate.
Strawberry and chocolate?
Right, but what taste does it have?
It's sweet.
It's sweet and a little bitter.
How do you know the difference?
From the aromas.
Because it's the smells. The mouth and the nose are connected.
Now, how do these students know so much about taste? Because at their school, they've been doing some experiments with slow food. Let's see what they've been doing. They're going to be blindfolded, and then we'll ask them to identify different types of fruit juices. So, what type of juice is this?
It's pineapple. It's pineapple.
I know what it is, but I can't think of the name. It's pineapple.
How about this one?
Orange.
Orange.
And this one?
It tastes like grapefruit. Like grapefruit.
It's sour.
But what fruit is it?
It's lemon.
Notice how mistakes can be made without the sense of smell? Let's see how chocolate can taste different.
It's a different taste.
This is chocolate.
The taste wasn't this strong before.
Chocolate is delicious with the nose unblocked.
When we eat, flavors are perceived by taste receptors. When we chew, aromas are released into the air to the nose, where they reach the olfactory receptors. The mouth and the nose are now in communication. Taste and smell work together to interpret the characteristics of food and beverages. When we have a cold or our nose is stuffed, our sense of smell is greatly reduced because olfaction is out of order. The aromatic substances in food are very important. In some ways, they represent their digital imprint. Now we'll try a useful exercise to detect the 5 basic tastes: salty, sour, sweet, bitter, and umami.
Now I'll have him drink water with salt. David!
What are you making me drink? It's so salty.
Now I'll have him drink water with sugar.
Good. Is it water and sugar?
Let's see if he can recognize lemon.
It's acidic. Is it lemon?
Correct. Now it is broth.
It's not very good. It tastes like meat broth.
You guessed everything right. And now, coffee.
But it's coffee. It tastes like coffee, but more bitter. What is it?
It's coffee without sugar.
Yeah.
taste buds found on the surfaces of the papillae of the tongue are small caps that provide receptors for every taste. When the receptors combine themselves with food molecules, for example sugar, an electrical impulse is transmitted to the brain for the final step of processing. To date, 5 diverse receptors have been attributed to the taste: sweet, bitter, acid, salty, and umami, the taste of glutamate. There are still many maps of the tongue that represent only 4 tastes focused in specific areas. These maps should be considered outdated because in reality, every part of the tongue is able to distinguish all the different tastes. There are sensations of taste which we perceive in the mouth, like for example spicy and astringent. Now we're going to see children from different areas of the world with different food cultures taste the hot pepper. You see, not everyone experiences spiciness with the same intensity. When we eat a chili pepper, the capsicum molecule is dissolved in our saliva, which is responsible for the spiciness. A burning sensation is triggered by the trigeminal nerve that also perceives heat, cold, and pain. Therefore, spiciness is not a taste, but a trigeminal sensation. This nerve is also stimulated by another molecule, methanol, from mint, which gives a sensation similar to coldness. There is another sensation that is different from taste that comes from such foods as artichokes and unripe fruit, and beverages such as tea and red wine. These contain tannins, a substance that reduces the capacity of saliva to lubricate, making the mouth seem dry and rough. This sensation is called astringency. Now let's see a simple attempt to recognize the aromas of food. We're using mint leaves, cinnamon, and lemon peel.
What does this smell like?
The aroma of mint.
What does this smell like?
It has the aroma of cinnamon.
And the last one. Let's see if you guess it.
I think it's lemon.
Great! You guessed them all.
Scientific explanation? We are able to distinguish odors and aromas thanks to a sensory organ called the olfactory epithelium, which interacts with odor molecules that enter directly from the nose and rise from the mouth. The olfactory epithelium is composed of millions of neurons with specific receptacles that combine odor molecules and then generate an electrical impulse. The neurons transmit the signal to the olfactory bulb and then to the cortex of the brain and simultaneously to the limbic system, the archive of memories and emotions. We have 350 different types of receptors that can perceive over 10,000 different odors when stimulated. There are some aromas like lemon or mint that are attributed to one single molecule. A single musical note or other aromas like apple or coffee consist of a blend of molecules, more like the sound of an orchestra. Aromas naturally present in food can be divided into a few groups.
The floral aroma of roses.
The balsamic aroma of eucalyptus.
The fruity aroma of strawberries.
The milky aroma of dairy products.
The herbaceous aroma of cut grass.
The spicy aroma of cloves.
The nutty aroma of dried fruit.
The toasted aroma of bread.
Tactile sensations are also important. not only touch, but also textures perceived in the mouth.
They're crumbly. It's creamy. That's
Sticky.
yeah. Sticky and smooth. It's rubbery. Those are crunchy.
Crunchy.
When we eat, we also perceive tactile perceptions like crunchy, rubbery, chewy, smooth, coarse, grainy, and viscous. These sensations provide information to the nerves on our taste buds about the consistency and texture of food. While chewing, we can also perceive through our sense of hearing if a food is, for example, crunchy.
Crumbly. Sticky. Creamy.
Rubbery.
Now let's see how Denise and David match adjectives describing tactile and auditory sensations.
Sticky.
Honey, yeah. Rubbery. Cheese. Cheese. And crunchy. That would be the carrots.
Well done. We have left sight for the very end, but in reality, it is the first sense we use to evaluate and select food. This is based on our past experiences and what we perceive as normal. With our sight, we choose which one is normal. Which bananas would you choose to eat?
Because these are mature. These are not ready, and these are overripe.
If your mother sent you to the store to buy beans, which ones would you choose? At first, the taste, trigeminal, tactile, olfactory, and auditory sensations involve a specific part of the brain, but then are conveyed to the frontal cortex where they combine into a single mental process. This final process of tasting food is what we call flavor.
Now we wish you farewell with each of our senses. The mouth,
Chow.
the eyes, the hands, the nose. The same ones we use to appreciate the taste of our foods.